All right, 9.2 is all about logarithms. Last section we learned about exponential functions, and this time we are learning about logs. So the first thing you got to know about logarithms is that they are the inverse of an exponential. So if we have an exponential function, the inverse of that exponential function is a log with the same base. So this one has a base of a for the exponential and has the same base a for the log. So if I was to take a log a of x, or if I was to do a log of a to the x, basically what happens there is you're left with only the x power. So this would cancel here, a base a exponential and a base a log, or vice versa, a base a log and a base a exponential. Okay. So in this section, we're learning how to use the logarithm to cancel out an exponential when we can't use a change of base where we're matching the powers. So the other thing that we got to look at is the graph. When we look at the graph of an exponential, we did this last section. We had a y-intercept of 1 was the classic one, and then we had it swoop down. This was an exponential, something like that. The main thing is that it had an asymptote across here. It had a horizontal asymptote. Now, if we were to flip that across the diagonal line, y equals x here, and to draw the log, it looks like the flipped over version of that. So first off, it doesn't have a y-intercept, it has an x-intercept now. It is curving downwards like this. Okay, so that second graph that I drew is y equals log base a of x. And instead of a horizontal asymptote, it has a vertical one here. So it's x equals 0. Okay, very similar to domain and range. The domain and range of the exponential function, domain was all real numbers, and the range was 0 to infinity. The logarithm graph, just like with any inverse graph, is the flipped version of that. So the domain and range, draw an arrow up here. We have the domain is going to be 0 to infinity, not included because it's not touching that asymptote. And then the range will actually be all real numbers. The opposite version of the natural log. Or sorry, not the natural log, the exponential function.